Hi, ladies. This is the end of your 12-4. Remember, we stopped, so you should have these notes. So go ahead and get them out. We have 3 theorems and then some examples is all to do. The first thing you need to notice about this theorems is that they're dealing with segments length instead of angles and arcs, like everything from the chapter was pretty much. We had some that were perpendicular and we did all that, but they're real easy. You just got to keep them straight. But again, the distinction is where they intersect. Okay, so these chords right here intersect somewhere inside the circle. Okay, so each individual segment, so A times B, is equal to C times D. It's real easy. You just got to remember it. Okay, so each individual piece when they intersect. So very simple. If you have 6 times 2 equals 4 times x, right? 6 times 2 equals 4 times x. 6 times 2 is 12. X is 3. Okay, so what's going to happen is you might get some not so pretty numbers, which is okay. You don't want to round, you just want to deal with what you got. Okay, this one is to secants again, but we're talking about this secant segments, which is W plus X. I left this page on here just so I could refresh. Remember, A to B is a secant segment. So is A to, let's say, that's C. Usually that's what we're talking about in these next ones. Okay, so W plus X is the whole secant segment. All right. X remembers from here to here. W is from here to here. So X plus W is the whole thing times the outside piece of the secant segment. If you look, it's from that point outside to where it hits the circle. That's the outside piece. And it's the same thing on the other one. The whole segment secant is Z plus Y times the outside piece. Okay, so simple example. All right, go secant. Let's say this is 5 and this is 6. This is X and this is 6. That's real simple, but 11 is the whole thing times 6 equals 6 plus X times X. Okay, so you might get into some quadratics. Also, I won't finish that up, but that's, you could also, let's say if we switch that up, 2 segments, we put the X here and the 6 here and the 5 here, the 6 here. That's 11 times the outside piece equals X plus 6 times 6. And then you got to distribute. Okay, so it's a lot easier. All right, the other one is tangent and a secant. All right, it's easy to remember because the first one's the same. You're going to take the entire secant segment, Y and Z, and the outside piece, Y, so it's the same as this one. But now when you have your tangent, you only have one piece, so in order to get the 2 pieces, you square it. Okay, so let's say this is 8, this is 4. Okay, so, and we're looking for T. 12 times 4, whole thing outside, equals T squared. And then you do whatever you got to do. 48 equals T squared. T equals, sorry about that pen, equals 48, which is radical what? C4 radical 3? Okay. So, products of the chord segments are equal. That's just the products are equal outside, and the product of the secant equals the square. So this is just written in words what we just said. All right, so let's pause and then work out number 1. So you're going to take, these are two secants. You're going to take the whole thing times the outside equals the whole thing. Whole thing times the outside. Okay. 14 times 6 is what? 84 equals distribute 7y. Oopsie, that's not right. Why is not the outside? 7 is. Silly me. Makes it a lot better. Let's try that again. I'm a little foggy here. I'm kind of sick. So 49 plus 7y. 7y equals, subtract 49 from 84. That's what? 35. So y equals 7. So I hope you got that one. Okay, pause again. Oh my goodness. Pause again and do the next one. Okay. This is a secant and a tangent. So we have one piece. We're going to take the secant whole thing, which is 16 plus 8, times the outside, which is 8, equals the tangent squared. 24 times 8. All right, let me just, since I'm going to take a radical here, I'm just going to divide it into 8, 8, and 3. There's that 8, and this is 8 times 3. So z should equal 8 radical 3. Okay, no rounding. All right, again, pause. All right, these are back to two secants. So it's like the first example we did up here. The whole thing times the outside equals the whole thing times the outside. Okay, 34 times 14. All right. 34 times 14. Enter. 476 equals 256 plus 16x. 476 minus 256. 220 equals 16x. Divide by 16. And 13.75. Okay. All right, do the last one on this page. All right, be careful if you take the whole chord. Sometimes that 3, you pick it up the wrong, but the M down here is definitely for this piece. It wouldn't be for that. So 6.5 times 3. Yikes, no. Times M equals 3 times 7. Each individual piece on the secant set. Okay, so I got 21 equals 6.5 times M. Sorry, this is so messy. Divide by 6.5. And M equals, what was that? 21 divided by 6.5. 21 divided by 6.5. Okay, let's see what that looks like. It's a nasty decimal, so let's make it a fraction. It's much better, 42/13. Okay, so we don't want to round. We just want to do what we got to do with that. All right, so this one's way more complex. So again, pause. Y is an angle. Z is a tangent segment. X is a part of a secant segment or part of a chord. All right. So sometimes, let's say we are going to start with this Z. So Z squared, that's the tangent segment, equals the entire secant segment. What is that? 9, 6, and 6. 9, 6, and 6 times the outside piece, which is also 6. All right. 9 and 6 and 6 is what? 21. 9 plus 12 times 6. So 126. Z equals radical 126. So Z equals, let's see, 126, I know, divisible by 2 is not a perfect square. Is it 4? Nope, 4 doesn't go. So 2, that's 126 divided by 2. Oh, that's 63. There's a 9 in 63. So let's try that. 2, 9, and 7. There's your 63. So that means Z equals 3 radical 14. Okay. All right. What about X? Okay. Let me erase here. X is this piece. This is 10. This is 6. This is 9. So 10 times X equals 9 times 6. Just be careful. Sometimes they're hard to see, but if you look, you're not going to make the mistake because like Y looks like it could be this segment, but it's a degree, so that's why it's not. All right, so there's Y. That's an easy one. All right, what about, or sorry, X. What about Y? Y is an angle. So Y equals, oh my, what the heck? Let's get these out of here. Maybe. Y equals 1/2. It's an angle formed inside. That was the lesson that we did last week. Or excuse me, yesterday. Last class, sorry. Okay, equals 1/2. So let's say intersect inside. We're going to take the sum. So 45 plus 85. 45 plus 85 is 130. Half of 130 is 65. Okay, so these are going to get considerably more complex than just what you've seen here. We're just doing the babies, and then of course they're going to get more challenging, which, forget it. Okay, one more. So again, pause. All right, measure of the angle formed by two tangents to a circle is 80. So you should have this figure. Oopsie, what? All right, circle. Whoa. Oh my goodness. Circle, come on. And two tangents. One here, tangent. One here, tangent. All right. So we are looking at this angle, right? Come on, right there. Okay, that's 80. So 80 goes there. All right, we have a point of tangency there, point of tangency there. All right, we are looking for both intercepted arcs. So let's call this X. What's the rest of it? 360 minus X. So 80 equals 1/2. 360 minus X, which is, I could do my half here. That would give me 160 here. 360 minus 2X. 360 minus 260 is minus 200. Minus 2X equals, X equals 100. Okay, so one of our cases is 100 degrees, and then 360 minus X is 360 minus 100, which is 260. So those are your two arcs. Okay, so that was really from the last. This is not our homework. The homework that you see on the thing has been adjusted. So all done.